So in 1994, several of us got together around a pretty neat idea. We liked DOS, but Microsoft was clearly moving to Windows. The next version of Windows, they said, was going to completely do away with DOS. So we wanted to keep DOS around, so we decided to write our own. And that project announced 29 years ago today, on June 29, 1994, was the FreeDOS project. And I wanted to show that it's not that hard to rewrite many of the core DOS utilities. You don't have to be an expert programmer to write some of these basic tools. That's what I'm going to show you in this video, a simple way that anyone can write some programs that replace these standard DOS commands. Now, I should mention these are not the best algorithms. In fact, there are better ways, for example, to read from a file, but I wanted to show how any beginner programmer can jump in and get started. And after all, I was definitely a beginner programmer in 1994 when I started working on FreeDOS. In fact, you can find some of these basic methods in my early code from 1994. So let's get started. So in 1994, I used the QuickC compiler, but these days I really like the IA16 version of GCC. You can install that as part of the FreeDOS 1.3 distribution. It installs under devel and then the IA16 or the i16 GNU directory. Now I've added in here a new batch file called mysetenv.bat, and that will, just to show you what it does, that will set my environment so I can compile programs with IA16 GCC. So it sets the DJGPP environment variable to point to the DJGPP environment file. It also updates my path to include the binary directory, the bin directory for the IA16 GCC. And it also creates an alias to the Fed editor. And that's my favorite editor whenever I do programming on FreeDOS. Let's go ahead and run mysetenv. And now let's go into my source directory where I've got a directory called FreeDOS, and we can now write some very simple versions of the original DOS commands. Now, one of them is a program called, or a command called echo. And so if I just do echo hello world, that will just print out the text that you've given it on the command line. So let's write our own for that. That's a very simple program to start with. So we'll do fed, and we'll do this one as necho.c. This is the new echo. And so if I run that, then I can just do include standard io.h. That's the same thing you're going to put at the top of pretty much every program is going to print output to the screen. And we'll do our int and then main. And we're going to use some arguments. We'll do int argc char argv. And let's do, we need to look through the command line. So we're going to use a variable for that called int, and let's just call it item. And then for item is 1. That's the first command line argument. argv0 would be the name of the program itself. And so here we're going to start at 1. And then as long as the item is less than argc, then we're going to increment item by 1. Item plus plus will increment it by 1. And then we'll just put out to the screen exactly the string that we've been given. Now, we could use printf, but we're not going to do anything in terms of formatted printing. So we can actually just use f put s, and then we'll put out the argv item to standard out. Now, that won't create a space between my entries, and so we're also going to then do a put char of a single space, and that will now add a space between each item. It'll also unfortunately add an extra space at the end of the command line. We could do some code to get around that, but for this, it doesn't really matter. And so that is the end of our loop, and then we can just do a final command, a final new line at the end of the output. We'll do a put char of a new line, and then we can return back to the operating system. And so if I save and close, then I can do a compile of necho. And now, by the way, there is no necho command on my system right now. So once I compile it, I'm going to be running this version here. And so let's do i16 GCC, and we're going to save the output to necho.exe, and we're going to compile the necho.c file. And once that compiles, now I can just run necho. Let's say hello world. And so that's printing out some text that I provide to it on the command line. So that's our first program that we can run that is basically replacing the echo command from DOS. Now, another thing you could do is there's a program called pause. And what pause will do is it'll just simply ask the user to press a key to continue before it moves on. And you use that a lot in batch files. Let's write our own. Now, there is no npause, and so we're going to start an npause program. So we'll do fed on npause.c. Now here, of course, we're always going to start with the include standard IO. And now we need to include console input. And so we're going to include conio.h. And now we're going to do an int. And now we need to, for our main program, and we need to be able to maybe ask the user for a prompt. But in this case, let's just make it a very simple program. So we're not actually going to take any command line options. We're just going to ignore it, any command line options that were given to us. And we're just going to put out the string. We'll just do an f put s that just says press any key to continue. And once we've done that, now that's an f put s. We actually need to give it what output stream to give it to, and that's going to be standard out. Now, that's not going to print out a new line. And that's intentional because I want the user to be basically holding on this prompt until they press a key. Now, we can use the getch function, and that will get a single character from the keyboard. And we're going to use that as a way to grab a key. Now, that is included in the i86 extra library from the IA16 GCC. It turns out we're going to have a problem if we just do an f put s and then immediately do a get ch, because that output is going to be sort of hiding and not flushed back to the screen. So we need to do what's called an f flush of the standard out. And so if you run your program, you don't get any output. It's because it's not pushed all the text back out to the screen. And now once we've done that, once we've now done the flush back to the standard output and we've grabbed a single character from the keyboard, then we can now do the new line. So we'll do a put char, and that will do a new line. And once we've done that, we can return back to the operating system. And now we've written a very simple version of the pause command. And so let's go ahead and save and quit. And we'll do the i16 GCC, saving it out to the npause.exe program of npause.c. Now we also need to link in that conio library. If you just try to compile it like this, it will give you a compiler error, and I'll run that so you can see what the compiler error looks like. So it says, oh, we don't know how to get ch, and so we're going to rerun that using -l of the i86 library, and that will include the getch function. And now we can run npause. And so now it's asked us to press any key to continue, and I didn't put the ... in there so that we recognize it's a different version than the built-in pause command. So we just need to hit any key in the keyboard, and I'll hit, for example, spacebar, and there it is. It's now exited the pause command. So that's another way that you can just sort of get started by writing programs in FreeDOS. Now let's try another one. So we can print files out. So I can print the source code. I can look at the source code of, for example, necho by typing, or npause by typing the file. So necho.c, and there's the source code to necho, or type npause.c, and then there's the source code to my file. And that's the type command. It will display the contents of a file. Now let's write our own version. Now this ends up being a very simple demonstration of files, but I'm actually going to make a modular version of a program to display the contents of a file, because what we're doing is we're reading from one file and I'm going to write to another. Basically, we're reading from one stream and writing out to another stream. The output stream is going to be a standard out in this case, but we can use that for other types of programs. And so I'm going to write a new file here. We'll do fed, and we'll do copy file.c. And we're copying because we're going to read from one stream, file stream, and out to another file stream. So we're going to do this one as include standardIO.h. Now this isn't a program. This is basically a library that we're building, just a function. And we're going to say, we'll make this a, it doesn't, we could read input from this to make sure that we knew how many things had been read, and we could then do an int, for example, or some sort of an unsigned long or something if we wanted to tell us the number of things that were read. In this case, I'm not going to care. So I'm just going to say void function here called copy file. And we're going to take a file pointer to an input and a file pointer to an output. And then inside here, we're going to go through a loop. And so we need a variable here. That we're going to read individual characters. And so I'll call it an int of ch. And then I'm going to do a loop that says, let's do it as a, we know that, well, let's go ahead and read while. Now there's a shortcut that we can do, where we can read the input, read a single character, ch equals f get c from the input. And you notice that I'm including it in these brackets here. So ch will now get the value of whatever was read from that stream, but it's also going to return that back in these sort of bracketed spaces. And so we can use that as an immediate comparison because it will return EOF end of file when it reaches the end of file. So as long as this character that we've read in is not an end of file marker, then we're going to do this loop. And in this loop, what we're going to do is just do a f put c of that single character on the output stream, right? So that's a very simple function that is now just going to copy one input to another output. There are better ways to read or copy files. I would use buffers, for example, but here is a simple example how any beginner programmer can get started. This will do the job, but just be aware, this is also going to be quite slow. So just be aware if you're trying to write performant programs, but this is meant for sort of beginner programmers to show that anybody can write these commands. Now let's also at this let's go ahead and open another file where it's going to be we'll call this one copy file .h, the header file for that. And so that any program that is going to use this function needs to know that this is a void function called copy file, and it reads from a input and it writes to an output. And so that is a function primitive prototype. And so now I should be able to save and quit all modified files. And so now I can use that copy file to write a new program. So let's do, actually, I should have stayed in there, but we'll do a fed on type.c. Actually, I want to do ntype. Now I don't have an ntype command on here, so we're going to write our own. So we'll do fed of ntype.c. And so we need to, of course, include standardIO.h. And now we can include our local file, include copy file.h. And now we can use the copy file function without having it in this file that we're reading. And so we're going to do our int main, and we're going to do an int argc and char of argv. And we need to look at the command line. So we're going to do the int of the item. And we also need to have a file pointer that we're reading from. And so we'll do a file of p file. And now we'll loop through the command lines to see what files have been given to us. It might be more than one. This is basically a version of the cat command on Linux. So we're going to do a for item starts at 1, and as long as item is less than argc, then we're going to do an item plus plus. That'll increment item by 1. Oops. And then we're going to just do an open. So we're going to do a file pointer. So we're going to do a p file is going to be an f open of that file that was given to us on the command line. And we're going to open that for reading. Now, it's possible that might not give us a valid a valid string or a valid pointer. And so we need to test for that. So we'll just say if the P file is null, then we can print out to the user, and we'll do a, let's just do a very simple version here using fprintf to standard error. And we'll say cannot open file, and we'll tell it what file we couldn't read. And that is from argv I. And there might be other commands or other files to read on the command line, so we'll just move on to the next one. We won't like exit back to the system, but if otherwise, we do have a valid file pointer, and so now we can do a copy file from that P file. That's the file that we're reading from, and we're going to print this back to the screen. So we'll do standard out. Now, once we're done with that file, we should close it. So we're going to do an fclose on P file. And now once we're done with the loop, we can now, oops, there's my ending curly bracket. And then once we're done with all that, we can now return back to the operating system with the exit code of 0. And now if I save and quit, I can do i16 GCC. And we're going to save the output as ntype.exe. And we're going to read from ntype.c and then also the copy file.c. And this should compile my program so I can now, and I used the wrong variable in there. So let's go ahead and fix that, ntype.c. And yep, right there. I used I instead of item, so we'll do items. And down here, we'll do item. All right, so now we can recompile our program, and that should give us an ntype command. And so now I've got ntype, and we'll just display the contents of copy file. Oops, copy file.c. And there it is. There's the contents. I can also print out at the same time the copy file.h file, and it'll put them both on the same output. And that's, as I said, very similar to the cat command on Linux systems. Now, if I also try to ntype a non-existent file, and so I'll just call it no file, you'll see that it says, oh, I can't read that file. And so that's a simple way that you can now create a program that will replace the type command. Let's do the same thing, but we're going to actually copy one file into another. And it's actually basically the same thing as what we did with type. And so I'm going to do fed, and we'll call this one ncopy. Now, we don't have an ncopy. That doesn't exist. So we'll do a fed of ncopy.c. And so we're going to do a include standard io.h, and we need to also include the copy file.h. And now we're going to do an int of a main function, and we need to be able to read from the command line int argc and char argv. And we need to, we're not going to actually iterate through the command line. We're going to assume that the command line has two files given to us, one file to copy from, another file to copy to. And so here we're going to just say we need the file pointers for an input and a file pointer for an output. And now let's check the command line. The usage should be ncopy of file 1 and then file 2. Basically, it's an input and an output. And so if that's the case, argc would be 3, because that would be an argument count including the argv0, which is the name of the command, and then file 1 and file 2. So if argc is not equal to 3, now we have an error. And now we can say, we'll just say f put s of the usage, and we'll just do a usage of ncopy file 1, file 2. And then we'll do a new line on that, and we'll do a print out to standard error. And if that's the case, we can now return back the operating system, because we can't do anything, so we'll return back with 1, indicating an error. Now, anything after this, we can now copy the file. because we know that we have two files. They might not be valid files. We might have been given a file that doesn't exist. So we need to be careful about that as well. But we'll first start with an fopen. Oops, we need to do our input is going to be an fopen of argv1. And we're going to read from that. And if the input is null, then that means that we could not read from it. And so we need to say fputS cannot open file. There's our new line, and then back to standard error. And then we can turn back to the operating system. And then we're going to open the output file. So we're going to do the out is fopen of argv2, and we're going to write to that file. Now that maybe we have we're trying to write it to a drive that doesn't exist, or maybe we're trying to write to a read-only file. So we need to check that as well. So if the output is null, that indicates an error. And so, oops, null, we should now check for that. And then we can say fputS cannot write to file. There's our new line printing out to standard error. And if that's the case, we should be good programmers and close the input file before we return back to the operating system. All right, so at this point, both the input and the output are working fine. So now we can do copy file from the input to the output, and then we can fclose the input, and we can fclose the output before we return back the operating system to indicate success. And so that is a longer program that basically is using the copy file function to copy the input to an output. And when we were doing the type command, the output was going to standard out. Here it's reading from one file and writing it to another file. So we'll do a file, save, and quit. And we'll be able to use the i16 GCC. We'll save that out to an ncopy.exe of ncopy.c, and we also need the copy file.c. And that should compile. And there we go. So let's do this. Let's do an ncopy of the ncopy source file, ncopy.c, and we'll just call this, we'll call it copy.c. And so now if I look at it, I should have two copies that are exactly the same size. Copy.c is 607 bytes, and ncopy.c is also 607 bytes. And now I know that if I do an n type of copy.c, I've got my full copy of the ncopy source code. So that is a way that you can write a program that will copy one program to another. Now, if I want to copy an executable, the same thing actually turns out works. Now there is no cpy command, and so let's do an let's do an ncopy of the ncopy.exe to cpy.exe. And so now I've got cpy.exe is 9266, the ncopy exe is 9266, and just to prove that this works, let's make a backup copy of the copy.c source file. So we'll do a cpy of copy.c to copy.back. And so, yep, we can copy text files, but also binary programs as well. So here you can see we've got a backup copy of copy.c as copy.back, and I used the cpy command, which was a copy of my ncopy command, to show that the cpy command is actually an executable program, and both the copy.c and copy.back are the same size. And now I can do an n type of copy.back just to show you that, yep, my source file is still there and it is correct. And so this is how you can write a simple version of that. Now, just for one more program, let me show you how to write a version of the choice command. So in the choice command, it's really just going to ask you for yes or no. And so you use that in a batch file to indicate success or failure. And so here I can do Y, and over here I can do N. We can write a simple version of that. Now, there is, again, no nChoice command. So we can write our own version and call it nChoice. And so let's do a fed of nChoice.c. Now, this is going to require reading from the keyboard. And so we can do that with, of course, we need to do include standard IO.h. And we need to use the console and the keyboard. We need to include the conio.h. And remember, that is provided to us using the -L I86 when we do linking at the end. So I've got a program here that doesn't actually need a function in it. I can just do it all inside a main function. So we're going to do an int main program. Let's not even bother with a prompt. So we don't need to take any arguments. And so we'll just do a simple program that will just ask you for an input. So let's just say we'll do a put s that says enter y or n, and then it will just give that out to the user. And we can now it's going to be on its own line because I use put s and not f put s, and that's okay. Up here, though, we need to have a variable to store the keyboard input. So we'll do an int variable called key. So now that we've asked for a prompt, we can now do a loop, and we can get the key that we're looking for. And so we'll loop and look for y or n, or lowercase y or lowercase n. And so that's what we're going to do here. So we're going to say, we're going to do a loop. And so if we do up front, then that will always make sure that the loop executes at least once. And we're going to do key equals get ch. So that's what we're going to do. We're just going to grab the keyboard input and store it into a single variable called key. And we're going to do this loop as long as we have some conditions here. So we need to check if the key is not equal to an uppercase y, and as long as the key is not a lowercase y, and as long as the key is not an uppercase n, and as long as the key is not a lowercase n. And so I'm using spaces around my parentheses so I know that I've got all of my parentheses matched up, because there's a lot there, right? I'm double checking. I'm checking to see if the key that was read from the keyboard is a y, or if uppercase y, or it's a lowercase y, or if it was an uppercase n or a lowercase n. And as long as it's not any of those four characters, it will continue doing the loop. Now, it turns out that get ch will return 0 if you enter in an extended character, and then you need to call get ch one more time to get the extended value. Here, we're just going to make a simple assumption that we don't need to do that. So just be aware that's the assumption that I'm making here. Now, once we've exited the loop, we know that the key is one of those four values, and we can return that value back to the operating system. So we're going to say if, and then we're going to do a comparison here. If key is an uppercase y, or the key is a lowercase y, then I'm going to return, let's just return 1. That indicates that the first option was chosen, so we know what that value is. And then we're going to say, well, if, and now we could do this as an if else, but you know, we've returned, so otherwise it's going to be an if. And so we can say if the key is an uppercase n, or the key is an uppercase or lowercase n, then we're going to return 2, and that will indicate the second option was chosen. And we know from the loop up here on the do while loop that our while condition specified that it can only be a capital Y, lowercase y, capital N, lowercase n. So we should be well covered down here with this if statement and this if statement. But I really like to have some other way to, just catch anything else that comes along. So we're going to do sort of a default exit. We should never get this. Should never get here. That just does a return back to the operating system of 0. That'll also keep the compiler from doing, any complaining about you're missing a return function or something. So we'll now write that back to the operating system, write that back to that file, and now we can do a compile of i16 GCC outputting to nchoice.exe. And there's our nchoice.c. And don't forget, we need to link in the i86 library. And this should give us a program that will read input from the keyboard. It's going to read it one character at a time, and it's going to wait for me to print or to enter in a Y or an N. And so let's go ahead and we'll run nchoice, and it's going to ask me for Y or N. So let's just type in a lowercase y, and let's echo back the error level. And now we know that came back as N. Let's do another nchoice, and we'll enter in an N this time. And we'll do another echo back of the error level. So you can see that if I enter in a Y or an N, it gives me back a return of a 1 or a 2. And so I just wanted to show with these simple programs that any beginner programmer can get started working in FreeDOS. You don't have to be an expert to write FreeDOS commands. And I certainly was not an expert back in 1994 when I started working on FreeDOS. So these were not the best algorithms for certain things. As I said, the reading from a file, there are other ways to do that where you use a buffer, but this is just a demonstration about how anybody can get into programming. So don't be afraid to start programming on your own. What do you think about that video? Let me know in the comments below. Otherwise, thanks to everybody who has been part of the FreeDOS project. 29 years is a long time for any open source project. Looking forward to more years to come. Before I go, I want to thank everybody who supports me on Patreon. You really do make this channel happen. I say that all the time, but you really do make the channel happen. Some of you are sponsoring me at a higher level, and I want to thank you especially here for that. Visit our website at freedos.org. Join us on Facebook. Follow us on Mastodon, and consider supporting me on Patreon. And don't forget to like and subscribe. Thank you.